Hello everyone. So this is a question from RE-NEET 2026. The lanthanide ion having 4 unpaired electrons is, okay, given atomic numbers of cerium is 58, neodymium is 60, terbium is 65, and holmium is 67, okay. So the chapters involved is D and F block. So the elements in which the last electron enters the n-2f orbitals, so those elements are known as F block elements. So last electron enters n-2f orbitals. So those elements are known as F block elements. And F block elements are also called inner transition elements. Okay, important. Okay, and those F block elements in which last electron enters one of the 4f orbitals. Okay, so those F block elements in which last electron enter one of 4f orbitals. So those guys are known as lanthanides or lanthanoids. Okay, and they are known as lanthanides or lanthanoids because they come immediately after lanthanum. Okay, so I have the periodic table. So here you can see that the this is my lanthanum, and after lanthanum I have these lanthanides or lanthanoids. Okay, so these guys are known as the lanthanides or lanthanoids because they come immediately after lanthanum. Lanthanum atomic number 57, cerium 58. Okay, and lanthanum is actually, so this guy is actually a D block element. It is still included in the lanthanoid series. So whenever we talk about lanthanoids, we always talk about lanthanum because it resembles the lanthanoids. Okay, because it also shows +3 oxidation state. It also shows similar metallic properties, and the ionic sizes are also similar. So therefore, lanthanum is also considered a part of the lanthanoid series. Okay, so you can see after xenon we have cesium. Okay, so the configuration of cesium will be sorry, so cesium will be xenon into 6s1. Then after cesium we have barium. So the configuration of barium will be xenon and 6s2. Then we have lanthanum, this guy. So the configuration will be xenon 5d1 6s2. Okay, after lanthanum the lanthanoids start, or the filling of 4f start from cerium. So therefore the atomic numbers are important. Xenon is 54, cesium is 55, barium is 56, lanthanum is 57. Important, remember this. Okay, because after 57 we start the lanthanoids. So 58 we have cerium, and from cerium 4f filling starts. So the configuration will be xenon 4f1 5d1 6s2. Okay, I'll put a star mark here. Then we have 59, which is praseodymium, and its configuration will be 4f3 6s2. Okay, important. Then we have atomic number 60, which is neodymium, this guy. So its configuration is 4f4 6s2. Important. Then we have promethium, atomic number 61, configuration 4f5 6s2. Then we have samarium, configuration 4f6 6s2. Then we have europium, configuration is 4f7 6s2. Then we have gadolinium, configuration 4f7 5d1 6s2. Important. Then we have terbium 65, configuration is 4f9 6s2. And then we have dysprosium, configuration 4F10 6s2, and then we have 67, which is holmium, configuration 4F11 6s2. Okay, I'll put a star mark here in terbium and also in holmium, because in the question they are asking us about the lanthanide ion having 4 unpaired electrons, and they have mentioned about cerium plus 3 ion, neodymium plus 3 ion, terbium plus 3 ion, and also holmium plus 3 ion. So let's talk about the options one by one. In option 1 we have option 1 or A, we have holmium plus 3. Okay, the configuration of holmium plus 3 ion will be, so this is our holmium. So remove 2 electrons from 6s and 1 electron from 4f, because the charge is plus 3. So we have to remove 3 electrons, 2 from here and 1 from here. So therefore the configuration of holmium plus 3 will be 4f10. Okay, one more thing, F subshell, remember, has 7 degenerate orbitals. Degenerate meaning they have the same energy, orbitals having the same energy. Okay, because for the F subshell the value of L is equal to 3, and therefore the value of M, magnetic quantum number, will be -3. It can be, it ranges from -L to +L, so therefore its value can be -3, -2, -1, 0, 1, 2, 3. So there are 1, 2, 3, 4, 5, 6, 7. That's why F subshell has 7 degenerate orbitals. Okay, so 4f10 will look something like this. So I will draw 7 orbitals. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So therefore you can see there are 4 unpaired electrons. Okay, then coming to option B. In option B we have neodymium plus 3. So the configuration of neodymium plus 3 will be, so remove 2 electrons from 6s and 1 from 4f. So therefore it will be 4f3. So which will look like this. 1, 2, 3. So there are 3 unpaired electrons. Okay. Next we have option C, where we have cerium plus 3. Okay. So the configuration of cerium plus 3 will be, so remove 2 electron from 6s and remove 1 from 5d. So we are left with 1 electron in 4f. Okay. So cerium plus 3 will look something like this. 1. So it has just 1 unpaired electron. Okay. Then we have the last option, which is terbium plus 3. So the configuration of terbium plus 3 will be, so remove 2 electrons from 6s and 1 from 4f. So we'll be left with 4f8. So it will be 4f8 and it will look something like this. 1, 2, 3, 4, 5, 6, 7, 8. So you can see there are total 6 unpaired electrons. Okay, so therefore the question is asking us the lanthanide ion having 4 unpaired electrons is. So out of the 4 options, holmium has, 4 unpaired electrons. So the correct answer will be holmium plus 3. Okay, thank you.